Okay guys, vertical angle theorem, we gotta prove this. Of course, we talked about vertical angles earlier in the year, and we even came up with a conclusion that pairs of vertical angles have to be congruent. Okay, so angle 1 and angle 3 form one vertical pair, angle 2 and angle 4 form the other vertical pair, and we've got to show that they are congruent. Okay, so let's see what we got going on. Let me get my given in here. Okay, so we say angle 2 and angle 4 are vertical. Angle 1 and angle 3 are vertical. That's our given. You could put this in here. Okay, line P and line T intersect each other. I usually just like to put this word diagram. Okay, and for me what that means is that all the information that I could pull from the diagram is included in the given. And so clearly you can see that lines T and P intersect each other. Okay, so we'll go from there. All right, let's see what's going on here. Okay, so I have to show that 1 and 3 are congruent, and I also have to show that 2 and 4 are congruent. So this is like almost like doing two different proofs. Okay, one for this and one for that. So I'll show you a way to deal with that. Okay, we're going to just deal with showing this, and I'm going to leave a little bit of room in between steps. Okay, and show you how to deal with basically doing two different proofs. Okay, so angle 1 and angle 3, I got to show they're congruent. Okay, so I have to get either angle 2 or angle 4 involved. I have to choose one or the other. Doesn't make any difference which one. So you just say, okay, I'm going to work with angle 2 or I'm going to work with angle 4. Okay, I'm going to work with angle 2. Okay, so 2 obviously, okay, is between 1 and 3. Okay, and so I said, well, why do I need this guy? Because I have to pull in, okay, the fact that they are supplementary, okay, using angle addition. Okay, and notice that 2 will be supplementary with 3 and it'll be supplementary with 1. Okay, so let's see what we can do here. Okay, now if I just deal with 1 and 2, okay, notice that if I apply the angle addition postulate, I can say the measure of angle 1 plus the measure of angle 2 gives me the measure all the way across. Okay, using the angle addition postulate. So we'll say angle addition postulate. Okay, so I'll say the measure of angle 1 plus the measure of angle 2 equals the measure all the way across, which would be 180 degrees. Okay, I like that. Okay, now notice I can say the same thing. Okay, you know what? Yeah, let's do this. Okay, I can say the same thing for 3 and 2. Okay, and since I am using the same reason, I can put it in the same step. Notice that if I take the measure of angle 2 plus the measure of angle 3, that'll give me the measure all the way across. Okay, so I can say the measure of angle 2 plus the measure of angle 3 equals 180 degrees for the same reason, angle addition postulate. Okay, all right, I'm going to leave some space there. Let me say, okay, well, how about this? 1 plus 2 is 180, and 2 plus 3 is 180. So 180, okay, obviously equals each other. Okay, so couldn't I just use some substitution here? Say, okay, well, if 2 plus 3 is 180, couldn't I substitute 2 plus 3 up here for 180 degrees? And when I do that, I get the measure of angle 1 plus the measure of angle 2 equals, okay, well, 180 is 2 plus 3, the measure of angle 2 plus the measure of angle 3. Okay, and all I'm doing is using substitution. Okay, now if you look here, notice that the same thing shows up on both sides. So couldn't I just do this, subtract the measure of angle 2 and subtract the measure of angle 2 from both sides? Okay, And so wouldn't I end up with the measure of angle 1 equals the measure of angle 3? And all I've done is just subtract the same number from both sides. So anytime we're subtracting the same number from both sides of an equation, that is the subtraction property of equality. Okay, now again, go back and erase any scratch work. That's why I'm erasing that stuff. Get rid of it. Okay. Now notice it wants us to say that the angles are congruent. Okay, so I have one more step. So right in the definition of congruent angles, it says that angles are congruent if they have the same measure. So if I say the measure of angle 1 equals the measure of angle 3, that's the same as saying angle 1 is congruent to angle 3, because it tells us that in the definition of congruent angles. Okay. All right, so we're good there. Okay, now I have to show that 2 and 4 are congruent. Okay, so let's go back up and notice how I've left some room, okay, in between steps to sort of add things in. So I've got to deal with 2 and 4. And so that means if I go about it the same way that I did for 1 and 3, I have to either involve angle 1 or angle 3. Okay, it doesn't make any difference which one you use, but you got to use one of them. So I'm going to involve angle 1. Okay, so what's the first thing I did here? Apply the angle addition postulate. Okay, and I had to do it twice. So we look up here and we say, okay, how about the measure of angle 4 plus the measure of angle 1? Wouldn't that give me the measure all the way across, which is 180 degrees? So I say the measure of angle 1 plus the measure of angle 4 equals 180 degrees by the angle addition postulate. Okay, so that gets 1 and 4, okay, involved. Okay, and so let's see, now I have to get 2 involved. Okay, well I said that I was going to work with angle 1. Okay, so let's involve 2 and 1. Okay, so these guys. I say, okay, what if I take the measure of angle 1 plus the measure of angle 2 right here? Okay, notice that that would give me the measure all the way across according to the angle addition postulate, and all the way across obviously is 180 degrees. So I say the measure of angle 1 plus the measure of angle 2 is 180 degrees, okay, because of the angle addition postulate. Okay, so now I'm working with these two guys, and we go down here, we use substitution last time. So notice I can do the same thing. If 1 plus 2 is 180, can I substitute 1 plus 2 right here for that 180? So I'd get 1 plus 4 equals 1 plus 2. Okay, so we get the measure of angle 1 plus the measure of angle 4 equals the measure of angle 1 plus the measure of angle 2. Okay, and that's just using substitution. Now I can put it in that same step because the reason's the same. Now we take a look here and you say, okay, well, what can I do with that? Well, notice the measure of angle 1 shows up on both sides. Remember, that measure, it's just a number. I don't know what it is, but it's a number. So couldn't I subtract the measure of angle 1 on both sides? Okay, and I'd be left with the measure of angle 4 is equal to the measure of angle 2. Using the subtraction property of equality, because all I did was subtract the same number from both sides. So again, go back and get rid of your scratch work. Okay, now if the angles have the same measurement, then by definition they have to be congruent. That's what it means for angles to be congruent. So the definition of congruent angles tells me that angle 2 and angle 4 are congruent, so I can write angle 2 is congruent to angle 4 by the definition of congruent angles. Okay, and there is your proof. And notice how leaving that little bit of space, okay, in between and then going back and adding things in helped out a lot, because I knew that proving this guy and proving that guy, the methods were going to be exactly the same. Okay, and so since I'm using the same reason to state all 4 of these, it only requires one step. And since I'm using the same reason to state these two, it only takes one step. And the same thing here, and the same thing here. Okay, so we get that entire proof done in 5 steps.